In this section, we'll do fractions and decimals. So the first part is just choose expressions that are equivalent. And late starting this video, so you can just kind of check those solutions there. Lowest terms, divide out the common factor. So 20 divided by 5 is 4. 35 divided by 5 is 7. Find two fractions that are equivalent to 9/11. So one of them is 63 over 77, and then we'll pick back up here. To get to 88, we multiply by 8, so you have to do that to both of them. So another equivalent fraction would be 72 over 88. The next thing we're going to do is just adding like terms. When adding fractions, you have to have a common denominator. Now, there's more than one way to do this. If you have the least common denominator between them, that's probably the quickest way. It'll be the smaller numbers. But worst case, if you're not very good at choosing that and don't want to spend the extra time figuring out, you can just multiply them together. If I was to multiply them together, it would be 135. I would just have to reduce more. But does anybody know what the common denominator is in this case? The least common denominator? It's going to be 45. So if I take 45, and I want to rewrite both fractions with the denominator of 45. All right. Like I said, with 45, it's going to be smaller numbers to work with. But if I didn't recognize that, I could have just said 9 times 15, which is 135, and worked it with that. It just means I'm going to have to reduce a little more. But that just makes you still be able to work the problem, even if you're not very good with identifying least common denominators. So how do we get from 9 to 45 right there? Times 5. If I multiply this one times 5, I have to multiply this one times 5. So 4 times 5 is 20 over 45. So the next one, how do you get from 15 to 45? Multiply by 3. Whatever you do to the denominator, do to the numerator. And we have now rewritten equivalent fractions with a common denominator. So for adding fractions, you can add the numerators. You get 32. And keep the denominator the same. I don't think anything reduces in that. So we should be finished there. Okay. Same thing for subtraction. You got to get a common denominator. What's our least common denominator here? 18. So 18 over 18. Figure out what you have to multiply this by to get 18. So times 2. Times 2, and then this one's times 9, times 9. Now, our fraction is just going to be over 18, but remember our rules for integers. When we did these, remember we would circle the number and the sign in front of it, so a positive 8 and a negative 9, different signs, subtract them. Take the sign of the larger number. When we're talking about the absolute value of the larger number, it's 9 is the bigger number and it's negative, so the answer is negative. If you have 8 and you subtract 9 from it, you're going to have negative 118. So also your rules for sign numbers is in there. Now we're going to move on to multiplying, and you can see over here where I have our reminder, because that's the last lesson we talked about. A negative times a negative is a positive, or a positive times a negative is a negative. Now we're also going to apply that to fractions. So for multiplying and dividing, we're able to cross cancel if possible. So for the multiplication problem, what I look for is I look to see if there's anything here and here in common. Any common factors? No. So that means I can't simplify there. So the next thing I look at is, can I simplify anything here or here? And the answer is no. So if you can't cross cancel and simplify, then just multiply and cross. So negative 6 times negative 1 is positive 6. And then 7 times 7 is 49. check to see if that reduces, and it doesn't. Okay. For the next one, it's division. So division, you remember you rewrite all division problems. So you copy the first term, change to multiplication, and flip the last term. Okay, now because it's a multiplication problem, I'm going to check to see if this and this, they do cross cancel, so they both have a 7 in common. So if I divide this by 7, I have 1. Divide this by 7, I have 1. And then I want to compare to see if this and this has anything in common, and they do. They both have at least a 6 in them. So divide by 6, divide by 6. After you cross cancel, you can multiply straight across. So we have 1 times 1 is 1, and 1 times 3 is 3. So division, rewrite by multiplying by the reciprocal. That's what we did, and some people copy, change, flip. Then afterwards, because it's multiplication, you can check to see if things cross cancel. I'm a fan of cross canceling because multiplication is a lot easier, but you can multiply straight across and then reduce the fraction if you prefer to do it that way. Recall in your memory about the 2 and 5/6 is called a mixed number because it's part whole number, part fraction. We can change it into an improper fraction. Remember doing these, we do 6 times 2, and then you add 5. So 6 times 2 is 12. Then we add 5, and that gives us 17. Always put it back over the same denominator, so 17 over 6. Some people do this. They'll do 6 times 2 plus 5, and they go in that order. So 6 times 2 and then plus 5. Always over common denominator. I mean over the same denominator, not common. Okay? Convert to a mixed number. These we just actually divide out. So you take your 21 and you want to divide by 5. The bottom the top number goes under the bar, so it's 21 divided by 5, and we just calculate that. 5 doesn't go into 2, so we don't put anything there, but we consider 21. 5 goes into 21 4 times. 4 times 5 is 20, with 1 left over. So this is we rewrite this fraction as 5 and 1 4. Oh, shoot. Sorry. 4, the answer is 4 and 1 left over out of 5. So I messed that whole thing up. 4 and 1/5. So the answer is 4, and then you have 1 remainder out of 5 parts. So 4 and 1/5. Find the difference. We're going to subtract. Anytime you add or subtract fractions, we have to have a common denominator. Now, there's a lot of different methods you can get into for doing this, especially with whole numbers. Sometimes people pull the whole numbers out, multiply them, work with just the smaller parts of the fractions, but that requires that you know which one's bigger or smaller from the beginning. The easiest, most consistent way to do it, if you do the same thing every time that works, is to what? Make them improper first, then get a common denominator, and then you can convert it back. That's going to be your safest bet. And if you want consistency and you like consistency, and something that works every time, that's my suggestion. So the first thing to do is 8 times 3 is 24, plus 2 is 26 over 3. And then this one is 5 times 1 is 5, plus 3 is 8/5. So first step, make it an improper fraction. Now I can look at the denominators 3 and 5 and find the least common denominator, which isn't too bad in this case. It's going to be 15. So how do we get from 3 to 15? Multiply by what? 5. If I multiply this by 5, I must multiply this by 5, which that's just going to be 130. Now over here, 5 times 3 is 15, so 8 times 3 is 24. We have a common denominator, so I'll leave it alone, and then I do 130 minus 24, and it's going to be 106. Now, if my math lab lets you keep it as an improper fraction, we might just have to look to see if anything reduces there, but if not, we would leave it. But since it started as a mixed number, let's return it to a mixed number form. All right? And to get it back into a mixed number, you take the top number goes under the bar, and we're going to divide this out like we just did. So 15 won't go into 1. So I'll move to the next one. 15 won't go into 10. So 0 there, but 15 will go into 106 about 7 times. 7 times 5 is 35. So it's 105. Our remainder is 1, so it goes 7 times. And then we have a remainder of 1 always back over that same. So 7 and 115. So the remainder becomes your numerator of your fraction, and your divisor is the denominator. Okay. We now have addition, and we also have division going on. But before we start, we need to simplify the numerator and simplify the denominator. And so I'm going to zone in on the top, and to add fractions, we have to have a common denominator. So before I start, I need to work with what's a common denominator with 4 and 2? Both of them can go into 4, that's easy. If I didn't see it, a safe thing is just multiply them together and use 8, but that's okay, you have to reduce more. So this one is already 4, so I'll leave it alone. Leave the first one alone. This one needs to be multiplied by 2 to get 4, so then I say 2 times 1 is 2, and this simplifies to 3/4. The bottom common denominator is 12, least common denominator here. To get from 4 to 12, I multiply by 3. So this one becomes 3/12. And on this one, to get to 12, I multiply by 4. So that's just going to be 7/12. Now, the notation, you're not as familiar with that notation, so if I rewrite this as 3/4 divided by 7/12, this is more familiar to you, and you can do, for division, 3/4, you can multiply by the reciprocal, which is 12/7. 3/4 times 12/7, so just rewrite that as multiplication, and then now what can we try to do? We'll look to see if we can cross cancel. If you prefer to multiply straight across and factor out later, that's up to you. But I like to cross cancel, so we're going to look at that. 3 and 7 don't have anything in common, so I just leave those alone. I check 4 and 12, and they do. Both of them have a 4 in them, so if I divide this by 4, I have 1. If I divide this by 4, I'll have 3. Now I just multiply across. 3 times 3 is 9. 1 times 7 is 7. 9/7, but what's that called? Improper. What could I do to make it into a mixed number? Divide them out, right? So it's going to go 1 and 2/7. If you want to do the extra work there and practice, you can. Find a rational number halfway between the two numbers. So now we're going to look at some problems where they give us two fractions. And they say, well, here's two of them. Tell me the rational number that's in between. So to get the middle, you add them together and divide by 2. So it's like this. If I take a string, I have a point on a string, and I have a point on another string. One of the simple things to do is to take it, fold the string in half, right? So that's when we're saying, like, add them together, take both ends, divide it by 2. So we have, first thing we got to do is add together. So we want to take 7/11ths and we want to add that to 1/6. To get a common denominator, we need to get least common denominator. Let's just go 66 here. Multiply by 6, so this is 42 times 11 here, times 11. So that's 53 over 66. And then our next step, after you add them together, we need to divide by 2. Or that tells us to do what? Multiply by the reciprocal. So I take the first one, multiply. What's the reciprocal of 2? 1/2, because it's 2 over 1. So when you do the reciprocal, it's 1 over 2. Check to see if anything cross cancels. In this case, there's not. So 53 times 1 is 53. 66 times 2 is 132. If nothing cross cancels, then you should know that your fraction should be in its most reduced form. So 53 over 132 is exactly halfway between 7/11, 11s, and 1/6. McKay's, find a number between 8/9 and 3/4 using McKay's theorem. Here's your note for McKay's theorem. So our note is to add the numerators, add the denominators. So, and that's the idea behind McKay's theorem. But so let's add the numerators. So 8 plus 3 is 11, and 9 plus 4 is 13. So the idea behind that is, if I have 8/9 and I have 3/4, it's saying that this is in the middle of them. It's between them. It just says find a number. Then that puts a number somewhere in the middle. Okay? So using McKay theorem, you could pick, that's not the same thing as find a number that's exactly halfway, right? So exactly halfway, you take the average. You add the 2, divide by, and then divide it by 2. For McKay's theorem, to find something in the middle that's an equality statement, using less than, we can just add the numerators, add the denominators to find something that's in the middle of them. All right, back to some practice we've done before. Write a fraction as a decimal. Remember we said the top number goes under the bar. And we start here. 8 does not go into 7. So put a decimal. Go ahead and bring it up, add a 0. 8 goes into 7D. 8 times. 8 times 8 is 64. 6 left over. 8 does not go into 6, so add a 0, bring it down. 8 goes into 67 times. 8 doesn't go into 4, so add a 0, bring it down. 8 goes into 45 times and get a 0. So 7/8 is equivalent to 0.875 as a decimal. Could have done this lesson on your own, huh? Find the decimal of 2 2/3. So go ahead and do this top number under the bar. 3, go ahead and be working this one on your own if you want. So we'll have what keeps happening? Same thing, right? So it's going to keep repeating. So it's 0.6. How do we describe that? With a bar. 0.6 with a bar. Right as a fraction. So this one just knows your place value. So what's position 1 to the right of the decimal? It's the tenths place, right? So if this is T-E-N, tenths, then you put 4 over a 10. It's place value. Put the number value over its place value, and then reduce. Both of them have a 2 in them. So reduce this. Divide by 2, divide by 2, and you get 2/5. What place value is this?
Hundreds.
Good. So hundreds. So you would put 25 over 100 and reduce. So divide by 25. Each one of them have a 25 in them. So you get 1/4. So from a fraction to a decimal to a fraction, put it over its place value and simplify. All right. So that's your brief overview of fractions, decimals. Next thing, we're going to do some applications of these things. We're going to use them and still just keep chugging away at some of the things that we do with them. So one of the questions is true or false? And you have 200% of 10 is 5. First of all, what is of a key indicator of with operation? Multiplication. So this is really saying 200% times 10 is 5. And then what do we always do with percent? We rewrite them as decimals when we calculate, right? And so if we have our little alphabet indicator, you have D to P. If it's a percent and I'm going to a decimal, which way do you go? So really it's, you can multiply that out, but here's what we remember the is over of equals percent over 100. That's been around for a long time. I don't know if you use that, but that's makes all of these easy, because even if I'm not good at setting it up, if I use this equality right here, this ratio, we can plug in everything that you know. So every time I write that down, and I always start like this, every single time. Every single time you start there, the 100 will never change. Now, where does this go? In the percent place, right? So here's the percent. So I put 200 here. Where does this go? This is of 10. So the 10 goes into what position? Of spot. And then is 5. So the 5 is the is. And so the question is, if you were to cross multiply that, is it true? Okay. Let me just put a question mark here, because we want to know, is that 5? Or better yet than just a question mark, let's put X, because it's easier for us to solve that way. So 100 times X is equal to 200 times 10. And then solve for X. Divide by 100, divide by 100, easy division there. So X is equal to 20. So it's saying that this is supposed to be 20. So is our statement true or false? False. Now, that's a kind of a little bit of an extensive way. This one you could have multiplied that out and see if that came out to be. whatever you want to do, but any of these percent with the is over X, percent over 100, I like to use that and set them up just because I don't have to remember anything, I don't have to change anything, I just literally can set it up every time. So this one we're going to say this is false. Just going to remind you about multiplying decimals. First thing you want to do is just count decimal places. This one is 1 decimal place, and the next one is how many decimal places? 1, 2, 3 numbers behind the decimal, so 3 decimal places. When you multiply, what do you do with those? How many will your answer have? 4. Good. So that's our little note to self. That's the only thing. Now come on to the side and rewrite them without decimals. So I'll say 831 times 0.667, which I don't even necessarily need that 0 there. And remember, for the first one we do 7 times everything. So 7 times 1 is 7. 7 times 3 is 21. Carry the 2. 7 times 8 is 56. 58. Now we'll do with the 6. 6 times 1. Remember, you got to line them up. I know it's been a while. 6 times 1. 6 times 3. Add a 0 as a placeholder. So you scoot over. I probably should have did that first. And then we add. Actually, let's do the last one. I'm not going to. Almost forgot this last one. So 6 times 1. Let me put 0. 0 as a placeholder, so that can be directly underneath this 6. So 6 times 1, 6 times 3 is 8. Careful to line them up. Now add down. 16 plus 6 is 2. I get 554,277. Now, what do we have to go back and remember? How many numbers need to be to the right of the decimal? 4 total, right? So you can start at the back and go 1, 2, 3, 4, or you can count them and know that there's 4 behind it, however you want to do that. So 55.4277, and we'll work on rounding some later. That's to the 4th decimal place. Divide fractions. When you divide fractions, we really want, if I was to set this up, it would be 0.47 divided by 0.1128. Now, what's the rule of thumb with dividing decimals? We don't want this to have a decimal place right here. Okay? We don't want that to have a decimal place, so to move it to, we also have to move this too. Okay, so if we move it to make a whole number for our divisor, then we need to do it to the other one as well. So first thing is just to rewrite that. And so that becomes 47 and then over 11.28. Bring the decimal up. Now it's just regular division. So 47 goes into 112. 47 is close to 50, so I'm gonna guess probably 2 times. If it's wrong, I'll fix it. So 2 times 7 is 14. 112 minus 84, so that'll be 8. Borrow from this, so that's 10. 47 will not go into 18, so drop the next number. 47 goes into 188. Let's try 4. 4 times 4 is 16. Okay, so that's nice. So it's just going to be 0.2. basic division rule, rounding. So you told me the 10th place is here. So if you want to go to the 10th place, put a bar under where you want your answer to stop. That means you will not write a number past that position. That's going to be the position that you're going to stop at when you give your answer. I always put a bar under the one that you're supposed to stop at. Circle the one behind it because the one behind it determines if this bumps up or stays the same. So what about 5 or higher? What's it do to the number in front of it? If it's 5 or higher, round up. So this is just rounded to the 10th place is 0.2. If they want us to go to the 100th place, that's hundreds is here. Circle the number behind it to determine if you bump or not. So because this is not 5 or higher, what do we do at 5? Leave it alone, right? So 852.15. Alright. Our reminder in the alphabet, decimal comes to 4%. So if you want to go from P 5% for this decimal, which way do we go? We're going from a decimal to a percent. 2 places to the right. So 1, 2, that's just going to be 28%. Now this time they give us a fraction. So to go from usually we have to go from a fraction to a decimal to a percent. When we're given a fraction, we have to go decimal first. So we'll turn it from a decimal and then a fraction to a decimal, and then from there we'll use our conversion there. All right, so we have to actually divide that out. Top number goes under the bar, the numerator does. 4 will not go into 3, so add a decimal and a 0. 4 times 7 is 28. 4 won't go into 2, add a 0, 4 times 5. So this is equivalent, 3/4 is equivalent to 0.75. So how do we go from decimal to a percent? We go to the right, 2, 1, 2, so that's going to be 75%. So this one makes us kind of use all three. First we have to do a conversion from a fraction to a decimal, and then we can change it. What is 55% over 282? We do is over of equals percent over 100. Every single time I start this, I start here. Then I start plugging in things that are given. 55 has a percent symbol, so it's going to be the 55 goes in the percent location. And of 282, of is 282, and they say what is. So is going to be what we're looking for, and I just like to let it be variable x. It can be anything. Once your ratio is set up, we're just going to cross multiply here. 100x is equal to 285 times 55, so 285. It is 282? Thank you. 282. Glad you caught that. Our numbers would have came out wrong. 282 times 55, which I get there. Divide both sides by 100 to get x by itself. Which means if you divide by 100, move the decimal 2 places to the left, so x is equal to 5.1. If you have the 0 there so that you can see that I moved 2 places, it's there. If not, that's also the same answer. We'll just try another one, different arrangement of these. So we have is over of equals percent over 100. I I'm going to let you just try to set it up. If you set it up, that's the important part. The rest of it is just cross multiplying and solving. The only skill that you need to know in this one is being able to set it up. And I said every single time this will be the case. We'll always start with that. But now you work on, see if you can set the ratio up correctly. Alright, so let's see. We get what percent of 380, so that's my of, is 152, that's my is. So the question is the percent this time, and that's what percent? That's kind of obvious. So cross multiply 152 times 100, and then I'll have 380 times x. So divide both sides by 380, and these zeros will cancel out. So 1,520 divided by 38, x is 40. So in this case, it said what percent. If you wanted to answer it, you could say 40%. All right. Now the next ones we said we were going to look at percent increase or decrease, and I need to give you a formula for that. So you take the let's just read the question first. So a sofa sells for $870. The sale price is $678.60. Find the percent increase or decrease. First of all, which one will it be in this case? Decrease, because it went down, right? It went on sale. So good. We know we're looking for a decrease, but here's our formula. You take the new minus the original price, the new price minus the original, and you divide that by the original. Once you get that, multiply it by 100 or move the decimal 2 places to the right. That's the same thing. All right. So in this case, what's the original price? $870. So I'm going to say this is the original, and this is the new price because this is what it is now. So we would say $678.60 minus the original price, 870, divided by 870. Remember our rules for integers. This one's a positive, and this is a negative. When you subtract different signs, subtract, take the sign of the larger number, subtract them, so we get a negative. You divide that by 870. If you go off to the side and divide that out, you're going to get 0.22. It's a negative. So the negative just tells you exactly what you expected in the beginning. It's a decrease. And then how do we move from a decimal to a percent? Right? So 22% decrease is how you would read that. Which we already knew from the beginning that it was going to be a decrease, but seeing the negative sign right there just tells us that's the read on it. Negative, a decrease of, move a decimal to a percent of a 22% decrease. So you can have this formula. The bill is $29.72. You want 15% of that. What would be the tip amount? This copy wasn't very good. You want to tip 15%. How much is that tip? Okay, so what you're going to do is you take the cost, 29.72, and you multiply it by, how do you write a percent as a decimal? You move it 2 places to the left, right? So times 0.15. So you take your total, multiply it by 0.15. This one has 2. Now it has 2, so you'll do the dollar amount afterwards. So go ahead and multiply that out and tell me what you get. $4.458. Round that because it's money, so it's going to be $4.46. So, any questions on that?